Okay, good morning. This is Mr. Schmidt speaking from cyber someplace. Today what I want to do is I want to have you look at a short video of my notes on vectors. You might want to take notes on a few of these things, but the key thing is not to worry about every single word, but to get across the basic idea, especially later when I show you how we're going to be adding vectors tip to tail. I'm going to give you a short lesson on the video. You can take notes, and then after you finish this, you can get the packet from the sub, get a protractor, get a ruler and a pencil, and you can start working on the packet. As usual, if you have questions on any of this, we'll take some time tomorrow to go through, or next week, and go through and clarify any questions you have. So I want to start just by reminding you that we have things called vectors and things called scalars. Scalars are just numbers. So everything you did in chemistry was a scalar. You add 50 milliliters of hydrochloric acid. It's a number with a unit. 5 jelly beans, scalar. Certain amount of coffee, scalar. It's just a number with a unit, that's all we mean. The number is sometimes called the magnitude. If you think about an earthquake, we say an earthquake had a magnitude 5.2. So magnitude is just a fancy way of saying the number, and then we have a unit. So those are scalars, and we certainly use scalars in physics, but we also use vectors. Vectors are important because, and they're different from scalars, in that they still have a number and a unit, but they also include a direction. And that turns out to be really important in physics. For example, if the quarterback throws the football 98 yards, that's a scalar, but towards the end zone. So there's a direction, so now it's a vector. You run a 5K or 3.1 miles east, vector, number, unit, direction. And a couple other examples, we'll talk about these in a minute. Because vectors include an amount or magnitude and a direction, it's useful to use an arrow to represent this. And we use the length of the arrow to represent how much. So a short arrow is a little, longer arrow is more. And we use the arrow point to say what direction we're going. So it's an easy way of doing it. Vectors, if I look at a vector, the vector has two parts. It has a tail, or the back, and it has the tip, where the arrow is pointing. So this might represent a quantity known as 100 pounds, a force of 100 pounds, certain length, and it's going east, it's pointing to the right. Likewise, we could say here's a quantity, 55 miles per hour, and it's going at a certain angle south of west. And again, we'll talk about this notation in a minute. So super easy concept, magnitude and direction, that's a vector. Now, I want to talk about how we describe this particular direction. And I'll be honest with you, this is a little bit of a pain in the neck, so if you're bothered by it originally, don't worry about it. We'll talk about it in class and clarify. But I think the best way of doing this is looking at this page. I have a few examples over here, and I'm going to try to describe 45 degrees north of east. You have to be careful. I want to say north of east, not east of north. So we need to be very specific. The way I do it is I look at the last thing first. I look at the last direction. This is my reference. So for example, I might say, I am taller than my wife. I'm comparing my height to my wife. So I am taller than my wife. That comes at the end of the sentence. Same thing here. We're going to look at 45 degrees north of east. So I'm going to come over here. I'm going to grab my pen, so bear with me. I'm going to start from my reference, which is east. So we have our typical north, south, east, and west. I'm going to start at my reference, the east, and I'm going to go north of it. I'm going to go 45 degrees. So I would take a protractor, but I'm going to go this way until it's 45 degrees. And that wasn't very good, but you get the idea. So from the east, I went north. So north of east. So that's A. If we look at the next example, take a second and see if you can figure this out on your own, and I'll do it. We're going to go 30 degrees south of west. So take a second to look at the graph, figure out where that would be. Find your reference, west. Then you want to go south of it, and you're going to go about 30 degrees south of it. So from the west, I'm going to go south 35, and there's my vector for B. So this is how we report it. And most people do it this way. I know in some of the math classes, they do it the exact same way. I'll do the next one, and then we can stop. So for C, I'm going to go 70 degrees east of south. So I find south, and I'm going to go to the east, and I'm going to go 70. So I'm going to come over here and say that's 70 degrees. Now, if you look at this one in particular, and it's true about all of them, I went 70 degrees east of south. I could have said, or 20 degrees south of east. It's the exact same thing. I don't care which way you do it. I kind of prefer you pick the smaller angle. So if we were doing C, you could go from the south and go 70 east, or you could go from the east and head 20 south. I don't really care which way you do it. I prefer the smaller angle, but if you did it the other way, that's totally fine. The key is make sure, and you look on the bottom of the page, you'll see the last direction and use that as your reference. And again, if you have trouble with this, just be, ask questions in class. Just be a little careful. We'll talk more about this later. When you add vectors, you have to be careful not to add them as numbers, and you'll see what I mean in a second. Now, I'm assuming you're pretty good with the protractor. Again, when I get back, we can go through and look at the protractor use. I'm going to skip ahead here. Now, what I want to show you in this, I would like you to take down your notes. This is adding vectors tip to tail. And the method is very, very simple. So we're going to take two vectors, and if you look at example 1, I'm going to have a vector which I've labeled A, and I say it's 3 centimeters east, so it has a magnitude and a direction. I've drawn it here. And I have another vector B, which is longer, 4 centimeters to the east. I want to add them, and just like we add two numbers and get a result, or a sum, I'm going to add two vectors and get a resultant. It's another vector that has a direction and a magnitude. Now, there's some steps over here, and if you want to copy these down, go ahead. I'm going to show you first how to do it, and then if you want to jot those down, go ahead. I'm going to, and you may not be able to see this, the quality of the font is not very big, not very good. I'll fatten this up a little bit maybe. So here's vector A. I'm going to take it, and I place the vector on the axis, starting at the origin. So I take the tail of the vector, the back of the vector, put it on the XY axis in the direction it's pointing. Because it's going east, the arrow is going east. I don't change the orientation. That's the first vector. Now, it's called tip to tail because I'm going to take to the tip of the first vector, I'm going to attach the tail of the second vector. So I'm going to grab this guy. Let me fatten that guy up too. A little easier to see. I'm going to grab this guy, and I'm going to attach to the tip of the first vector, I'm going to attach the tail of the second vector. So here's vector A, haven't changed it. Here's vector B, haven't changed it. And now I have a new vector that goes from the origin to the tip of the last vector. And this is called the resultant. I'll grab and draw an arrow to represent it. Let me make it red and fat. So the resultant vector always goes from where we started, and it goes to where we ended. And because we started at the origin, I'm drawing a little bit below so you can see it. But because we started at the origin, it's kind of like we walk. We start here, we walk over here, we walk over here. What we really do, we walk from here to here. So you add those vectors. We're simply adding tip to tail. Now in this case, and this is a unique case, we went 3 east and we went 4 east, so we really went 7 east. So the resultant is this red thing, and we did actually travel 7 east. So in this case, we can say 3 plus 4 is 7, but be careful, that's not typically what we do. Let me illustrate what I mean by that. And again, the notes over here, if you want, you can stop the video and jot these down if you want to, and you can replay the video if you want. Let me show you another example and just show that it's not always the same. And this one I'm going to do on the board with my pen, so bear with me. I have the same thing. I have a vector A, and I'll take A and I'll draw it in blue. And it says 10 newtons east. Newtons is just a unit in physics. I'll just draw it a certain length. So I'm going to start at the origin. I'm going to go 10 to the east. There's vector A. I have my arrow pointing east because that's the way the vector is going. Then to the tip of A, I'm going to attach B. B goes 5 newtons north. So I'm going to go in the north direction or up. So just thinking about a map, north, south, east, and west. And now I've attached these tip to tail. Now the resultant always goes, and this is a mistake people always make, the resultant is the shortcut. I walked out on A and then up on B, or I could have just gone directly from the origin to the tip of the last vector. So it's from where I start to where I finish, and this is the resultant. The resultant always goes from the origin to the tip of the last vector. Okay? So again, just be careful. So this is kind of the key statement, from the origin to the tip of the last vector for the resultant. So adding vectors is super easy. Nothing complicated at all. You're just making a drawing. Now the only thing that gets even slightly complex is how do we calculate, or how do we determine how long this resultant was? And again, if I go back here, this was easy. I went 3 plus 4, oh, that's 7. We were going in the same direction. You have to be careful here, because here I walked 10 east and I walked 5 north. This length is not 15. You can't simply say 10 plus 5 is 15. In fact, we know from this is why we studied the trig a minute ago, we know that to actually calculate the resultant, we'd have to use the Pythagorean theorem. We have one leg, we have the other leg, 10 and 5, and we could calculate the length of this, and it would not come up to be 15. So this is why I was showing you the math, not to make life miserable, but to actually use this when we actually do vectors. So just be careful to make sure that we don't add them as numbers, add them as vectors. And again, I'll talk more about that later. So the process of adding vectors is very, very simple. We could do it with a bunch of cases. I'm not going to do all these. You're going to work on a packet in a minute that requires you to do it. Now, the thing you have to pay attention to in the packet is that it's going to say measurement method. You could actually measure the resultant. I could come over with a ruler and measure how long it is, and I could take a protractor and measure the angle. So on the lab packet, it's going to say use the measurement technique, and you use a ruler and a protractor. If I ask you to do the calculation technique, we're going to have to use, here, say calculation method. You're going to have to actually use SOHCAHTOA to get the angle, and you're going to have to use Pythagoras to get the length. So again, pay attention to whether I'm asking you to calculate or I'm asking you to measure. The other thing you have to be careful about is giving specific directions. You can't just say north or east. You actually have to calculate that angle and tell me 15 degrees north of east or 35 degrees south of west. So let me very quickly do this example on the board. I picked nice numbers. So here's example 3. I'm going to start with A, and I'm going to go 3 centimeters south. So I'm going to start at the origin, go 3 centimeters south. So there's A. I'm then going to the tip of A, I'm going to attach B. I'll do this one in blue. And I'm going to go out 4 centimeters west. And again, I'm not scaling this. You are going to when you use your protractor and ruler. So there's my vector B. So B is in blue and A is in red. Now my resultant I'll show in green. And remember, my resultant always starts at the origin and always goes to the tip of the last vector. So there's my resultant. To calculate this, again, we have a nice right triangle here, so we can use Pythagoras. We have a side, and we have a side, and we're looking for the hypotenuse. So I can use ESNA. I can say, well, Pythagoras says a squared plus b squared equals r squared, or if you want to call it c squared, that's fine. And therefore, r must equal the square root of a squared plus b squared. So we're doing our solve step. I now put in numbers. I'm going to say, well, that's going to be 3 squared plus 4 squared, square root. That looks like the square root of 25, and so my resultant is going to be a length of 5 centimeters. But be careful, we're not done. That's just the magnitude. I also have to get the direction. By the way, you may have noticed this is a 3, 4, 5 triangle, if you remember that from math class. If you don't, that's fine too. To get the direction, I'm going to have to use trig. And again, if I look at this, because we have all 3 sides, we know this is 5, this is 3, and this is 4. And I'm looking for, doesn't matter, any angle. I'll take any of them. You could take the smaller angle up here or this angle. But get the angle in the triangle. I'll be pretty lenient in which one you do. If I'm looking for this angle theta, well, I look at this and I say, hey, I know the opposite side over here. Sorry. I know the side B, which is opposite, and I know the side next to it, which is adjacent. So it looks to me like tangent. So I'm going to say tangent theta is the opposite over the adjacent. Therefore, theta equals the inverse tan of the opposite over adjacent. Theta equals the inverse tan of opposite would be 4, the adjacent would be 3. And I'll be honest with you, I don't know what that is. Just say for ha-has, that's 58 degrees. I really don't know. But it's 58 degrees. Remember, we're measuring this angle in here, so I'm going to say from the south, I went west 58. So it's west of south. Now again, don't worry about this too much. So here I have my vector, it's the magnitude and unit, and here's my direction. So I have the resultant vector. So like I said, in the lab packet, it's going to ask you to do it tip to tail measurement. You would just grab a ruler and measure that, take a protractor and measure that, that'd be fine. Or if it says calculate, you have to do the math that we learned earlier. All these problems are the same. There's a zillion different ways of doing it. We're not going to go nuts. The lab you're going to do, the lab rep you're going to do, we will talk about and make sure everybody is fully comfortable with that. So watch the video once, take some notes on it. If you want to watch it a second time, go right ahead, and hopefully this will make sense to you. And hopefully the video worked. All right, I'll see you guys on Friday, and we'll talk about it. Thanks.